Okay, let's look at the homework 4.9, problem number 7. So I have to put number 7 here. Alright, so in this problem, we have a second derivative given. Then we want to find the original function. Alright, so let's do that. So if you have a second derivative, in order to go back to the first derivative, we take the antiderivative. Alright, so f prime of x, right? I mean f prime of t, right? Variable is t in this case, is the antiderivative of the second derivative, which is given here. So it's 8 e to the t plus 3 sine of t with respect to t. Right, so this is going to give you right, so 8 is a constant multiple, so just put it in front. Antiderivative e to the t is e to the t, right? Then plus 3, so you have a plus 3 is there, right? Antiderivative sine of t is actually a negative cosine of t, so it's a cosine of t, right? But it's going to be a negative cosine of t, right? Then you would have plus some constant, so I'm going to call it constant c1 because I might have to deal with another constant. All right, then so this is the best we can do. Then we want to find the original function f. So if you want to go back to the original function, we take another antiderivative of what we just found. So you have 8 e to the t minus 3 cosine of t plus c1 with respect to t, right? So if you do that, so you have 8 e to the t, antiderivatives are still 8 times e to the t. Alright, so it's going to be negative 3, just a constant multiple. Right? Antiderivative cosine of t is just a sine of t. So sine of t. Right? Now this is a little tricky, but the antiderivative c1 would be c1t. So c1 times t. Then you might have some other constants, so I'm going to use c2. So that's why I wanted to call it c1. So we can see that this guy is different from C2. All right, then we can use the condition here. So using when t equals 0, function is 0. So plug in t equals 0 into the function. Right, this would give you 8 times e to the 0. So 8 times e to the 0 is 1, right? E to the 0 is 1. Minus 3 times, right, sine of 0 is 0, so times 0, so that's 0, and you have a c1 times 0 plus c2, right? So you can see that let's see, this is just 0, so I cross that out. This is 0 also, so you just have a 8 plus c2, so this is 8 plus c2, right? This is supposed to be 0, right? Which means that by subtracting 8 from both sides, we know that the c2 has to be negative 8. All right. Then we plug in pi, so we have f of pi. All right. Then you have 8 times e to the pi, so I guess we can't really do too much to simplify, and you have a negative 3 times, right? Sine of pi is 0, so it's times 0, right? Plus c1 times pi, right? And plus c2, actually c2 is negative 8, right? So it's negative 8, right? And this is supposed to be equal to, let's see, let's just simplify. All right, 3 times 0 is 0, right? So you would have 8 e to the pi all right, plus C1 pi minus 8 equals 0. All right, so we can solve for C1. So C1 is going to be, first I'm gonna put let's say add 8 so that we can send negative 8 to the other side, and I'm gonna send this guy to the other side as well, so we can just subtract 8 e to the pi. Right, so you get that pi C1 pi is equal to 8 minus 8 e to the pi. Right, maybe we should just factor out 8 to make it look nicer, so it's a 1 minus e to the pi. Right, but if you want C1, we're gonna divide through by pi, so divide through by pi, so C1 happens to be 8 over pi times 1 minus e to the pi. Alright, so therefore original function f of t is equal to, right, this is 8 e to the t, right, minus 3 sine of t, right, then C1 would be, we just found that 8 over pi times 1 minus e to the pi times t, and a C2 is negative 8. Right, so that's the function f of t that we are looking for. All right, so let's type it in. All right, so the answer we found was 8 e to the t minus 3 sine of t plus 8 over pi, so pi would be in Greek, pi times 1 minus e to the pi again, right, and then times t minus 8. Right, so let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.